We'd like to thank Cloud Foundry, our sponsor, for these podcasts from Cloud Foundry Summit in Frankfurt, Germany. Cloud Foundry gives companies the speed, simplicity, and control they need to develop and deploy applications faster and easier. It's open source, easy to iterate, and built to scale. Learn more at cloudfoundry.org. All right, hey, it's Alex Williams at the Cloud Foundry Summit in Frankfurt, and we're here with my friend and CEO of Cloud Foundry, Sam Ramji. Hey, Sam.
Hey, Alex. Great to see you, man.
Good to see you. Well, we were just talking about the success of this event. Can you tell us how this compares to other events that you've had?
It's crazy. So we have 706 registrants as of today. I think almost all of them showed up. 10 months ago, to put in perspective, last November 2015, we had an event in Berlin. We had 456 attendees, so we're a little over 50% growth in only 10 months. If we compare it to the trend of Cloud Foundry Summits in the US, I think this is already bigger than the second Cloud Foundry Summit in the US, so the 2014 Summit. It's just on an amazing roll. And surprisingly, as you've seen, if you want to be an open source summit professional attendee, and go to all of them, you could be on the road 50 weeks a year.
Oh, I know that.
So I was talking with my friend Jim Zemlin, who runs the Linux Foundation, and he was saying, you know what, just be satisfied with holding steady. Like if you just get the exact same attendance as last year, that's the new growth, because it's so diluted.
So much, yeah.
But instead we grew 50% at this event, so it's pretty extraordinary. I'm very excited.
So what would you say are the dynamics of that growth?
I think Europe is a burgeoning place for Cloud Foundry. I think Germany, particularly with Industry 4.0, and you've got Siemens and Bosch and Philips and all the automotive manufacturers, where you've got VW, Daimler, BMW, and SAP, obviously, as global leading software company, ISV. That's a huge core of critical mass, but beyond that, you've got the UK government, you've got the Dutch government adopting Cloud Foundry, you've got financial services, you've got heavy industry, you've got tech companies, you've got healthcare. Allstate has a division here, right? So as the world becomes more globalized and global companies use Cloud Foundry, I think you've got this sort of upsurge of active participation in the events because people are actively using Cloud Foundry to drive their business.
Can you attribute any of the increase to iterations in the technology architecture itself?
I think that's fair, actually. We've found that adoption has two maturity curves, right? There's a technology maturity curve. How well understood is this? How hardened is it for production? And how easily can you integrate it with all the other systems that you depend on? I think the reason the first wave of PaaS kind of faded early is that platform as a service didn't imagine itself as something that connected to existing systems. It was the cool, shiny, new, sandbox, greenfield applications only. But when those don't connect to your enterprise systems, it's not really enterprise software. So this second wave of platform as a service that we're in, with Cloud Foundry leading the way, is entirely built on the idea you can have really hardened runtime production apps that are talking to hardened runtime enterprise legacy systems of record. And that way we bring the whole enterprise forward. So I think that's the technology maturity side.
So when you think of that, and think of the technology adoption, the business adoption, what did you think about how this event should be planned for? What were some of the themes that you were thinking about? What went into the planning of the event that led to what we see today?
So the two big themes that were coming in terms of the maturity on the business side that led to this were multi-cloud and then industrial internet, or Internet of Things. As you know, I kind of feel like things is a super vague word and intellectually lazy, but that's kind of what we're stuck with.
Right.
But you've got industrial internet, large fixed systems, power generation plants, transportation systems, ships, right? So they're not all fixed, but they're all huge, that now have to be reasoned about. They have to be computed and analyzed with new sensors. You got wearables and drivables, actually, which is kind of how I think about automotive, right? Drivables, and then you've got multi-cloud. So one of the interesting things about Europe, I think, as a geography, is naturally a sense of conservatism around US-centric companies launching public clouds. So yes, there is AWS adoption here. Yes, there is some Azure adoption here. Europe is very .NET and sort of Microsoft technology friendly. There's some Google Cloud Platform adoption here, but there's also a lot of national telecommunications companies building their own clouds. There's a lot of still on-premises data centers that are getting bigger. They have much higher concerns for citizen data privacy. So the idea of multi-cloud being core to how Europeans come at doing cloud computing, I think has made us really relevant here. And then combining that with the IoT workloads, we're just seeing a lot of growth and a lot of inbound interest, both from users, vendors, and frankly, press and analysts. Everybody wants to know, hey, what's going on?
It seems like we're starting to see like the constellations starting to form though around IoT, where it's not so abstract, right? So
yes,
cloud used to be a very abstract term, but we can now quantify it in many different ways.
Yes.
Now, it seems like we're starting to be able to quantify IoT a little bit. Like, for example, for me, in talking with people yesterday at your own conference about serverless architectures and how they can be used in an IoT environment for the batch processing of sensor data, right?
Yes.
Things like that.
That's a really neat observation. So I had the opportunity to spend a few hours yesterday with Chad Aramura, the CEO of Iron.io, as well as Bart Schachter, who's the Chief Operating Officer. I think they started in 2011, which coincidentally is the year that Cloud Foundry became public and open source.
Right.
Started working on this idea of a serverless architecture back then. I think serverless is an interesting name for that design pattern.
Right.
I prefer event-driven.
Yes.
I think serverless is,
event-driven is much better.
Yeah, serverless is kind of getting a little bit of a buzz, but it's really event-driven. So if you look back 10, 15 years ago, we started seeing the introduction of very scalable but monolithic complex event processors. And I remember a company called iSpheres back then, which was amazing. They could do 1 million rule evaluations per second, and they were being deployed to military environments to build a shared battle space. The real innovation there was, hey, you've got all these different sensors. They're all putting out this mad fire hose of data. What distinguishes a event, right, or these kind of pieces of data coming back versus something that you need to alert a person to, is very hard to reason about, right? Rules, separation in time, you need to aggregate something that happened 5 minutes ago with something that happened now and say, oh, this is an alert. Pay attention to me. What's happened in the last 10, 15 years is now as we get the wave of IoT in, architectures are flipping upside down. You don't have just one consistent fire hose of web browsers hitting your front-end system, standing up with your web server. You've got this cascading, somewhat chaotic, high-scale set of small messages hitting your engines. You got to be able to pull all that data in, and then you have to be responsive with an event. It's a very different architecture. It's not even really a microservices architecture, although events could trigger microservices. Somehow you have to be able to reason, did an event happen? So that, I think, is maybe a more interesting and durable pattern than simply calling it serverless. Now, if we're ditching things, then we could call Cloud Foundry's developer experience containerless, but I'm not sure that sticks with what people want to hear either.
Someone asked if Cloud Foundry itself could be described as serverless in itself. I think mostly thinking about how it serves as a back-end system in itself. And my first thought, is about BOSH.
Sure.
And the role that BOSH plays as a comprehensive architecture for event-based environments.
That's an interesting thought. So BOSH has seen some major renovation in the last 12 months. One of the fastest moving projects in Cloud Foundry, as you know. BOSH is really the secret sauce that makes Cloud Foundry not only unkillable, because BOSH will keep resurrecting all the Cloud Foundry processes, but it also makes Cloud Foundry multi-cloud. Right? We treat every cloud as if it's a piece of hardware, effectively. Right? You've got a BOSH CPI, which is like a driver for a cloud. So BOSH is critical for delivering on Cloud Foundry's multi-cloud promise. But we are starting to see BOSH be a host in and of itself. It's a platform for stateful services that want to get tracked into an application lifecycle. So we're seeing, I think Pivotal's bringing out a concourse BOSH deployment. We've got BOSH deployed Redis and Mongo and various data sources. Some of those things, like there's a BOSH deployed Kafka, that's a great event sink for all of this data to go into,
right.
And then for Cloud Foundry applications to be able to pull information out of a source as big as Kafka, or Spark, for that matter. So I think BOSH is a really interesting platform. Above it, Cloud Foundry, though, the Elastic Runtime, with the new generation of our container scheduling system with Diego.
Right.
We've actually taken a leap forward there, both in hardening, but also in working with OCI standards, right? We're able to run, OCI compliant runtimes and container images, which you've started writing about pretty interesting changes that are happening right now in terms of Docker and Kubernetes, and everybody's starting to have a different opinion on containers, which is funny to me because I got a lot of criticism when I took over Cloud Foundry a year and a half ago, like, oh, why doesn't Cloud Foundry just get on the Docker thing? And the historical stance of the Cloud Foundry engineering team was like, hey, we kind of almost invented containers because we built Warden,
right?
And now we've updated that with Garden. Nobody wanted to hear about the detail.
No.
Everybody wanted Docker, 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 Docker. Now we're coming through a phase where we've already harmonized with Docker. Now Kubernetes is leaving Docker, so it's becoming sexy again as we start to look at different platforms built for different purposes that you might need to have slightly different opinions about the container runtime.
While thinking about long-term sustainability.
While thinking about long-term sustainability and making sure that we have a consistent container image format, which is a critical piece of inventory that's being developed by the thousands every day that we need to preserve for sort of future usage. You can start to think about a container image as instant legacy, and the job of enterprise-grade platforms for the next couple decades will be to be able to continue to have those become runnable objects in whatever version of the platform or whatever hardware we're running on in the future.
It's funny, that story that you're talking about that we've been writing about, kind of the, through the discussions about what's going to happen in the Docker community and what's, is there a fork or not, and one of the things I've learned through this process is that the definitions are changing so much.
Yes.
Right? It's not. It is a changing. There is a discussion about changes in the code, but that's just almost like a daily iterative thing anyway. This is more about changes in communities and how communities are defined and how the communities are formed, then how that relates back to the technology itself. It's a people issue.
That's a really interesting point. To dive into the changes in code, I think of changes in code are a way to measure how we're sensing the shape of the problem. So I think we sat down a year ago and I said, Alex, I've been talking with VCs.
Yeah.
There's 42 VC-backed container companies in Silicon Valley at that time. Remember that?
Yeah.
I think it was like 2015, maybe July, might have been at OSCON. That's proliferation. What that tells you is that the space is still yet not well enough defined.
Right.
All of this code has to go out and explore it. It's almost like finding a landscape by Braille. It's kind of what we do with code. When the code velocity slows dramatically, we can start to say, oh, that problem's settling down. We kind of know the shape of it. So one thing that I've also fielded a lot of criticism on lately is, you're putting all this effort into Diego. Why don't you just move Cloud Foundry over to Kubernetes? And I say the same thing. Like, these spaces are not well enough understood to standardize them. If you look at the velocity of Cloud Foundry, you look at the velocity of Diego, look at the velocity of Kubernetes, look at the velocity of Mesos, look at the velocity of Docker. These are all still fast-moving projects. If you force them to depend on each other in an arbitrary way just because at a 100,000-foot view it looks like a pretty architecture, you will actually die in implementation. It's a very pragmatic viewpoint, but we all believe in shipping code that works. So we have to be wedded to the pragmatics of it. Does that make sense?
Yes.
So if the velocity is still high, don't force premature standardization. I think 18 months from now, we will all have kind of gotten a much better sense of what a container is and maybe what are the edges of container orchestration by itself. Maybe then we can start to standardize that more effectively. In the meantime, what's great that's changed dramatically in the last 18 months, looking backwards a year and a half, is we've all started to talk with each other. Previous competitors holding kind of, knife edge conversations with each other, feeling very hostile and aggressive. I think a lot of these conversations are starting to settle down, and the humans that you referred to, the community overall, is now having open discussions to say, how many opinions can we have about containers? What are we trying to do here? Can we part ways for a little bit so we can do some experiments and try to serve our needs? Doesn't mean that you won't link up again in the future, just like Node.js and IO.js, but being able to say in a very pragmatic fashion, how do we solve our problems with the code we've got and with the people we've got? That's what I'm starting to see, an active, open, and I think participatory conversation.
So how does that affect the trajectory of the Cloud Foundry Foundation and community?
The Cloud Foundry Foundation's trajectory is set primarily by Cloud Foundry community adoption. So when you look at what we do, we're here to certainly to shepherd the open source project itself, to ensure good and fair cooperation among the vendors, and to be able to build new opportunities for developers building on Cloud Foundry. So when we think about what's our job, it's to grow the ecosystem. How do we do that? We do that through certification. So we certify and make sure all of the vendors are playing by the rules. They're using a compatible Cloud Foundry. They're calling it Cloud Foundry. And then we're developing developer training and certification so that enterprise developers, enterprise makers can get proven stamps, right? Like micro certificates, micro badges, micro degrees, saying we understand how to deploy software to Cloud Foundry. We understand how to write a microservice. We know how to scale it. That's really where the foundation's main thrust is. However, because we are a nonprofit open source foundation, we also get to work horizontally with other foundations. So a great example of that is our work with the Cloud Native Computing Foundation, which I think you're aware of.
Yeah.
But for your listeners, we have been working very strongly with the CNCF, notably, and probably surprising to many of your listeners, with Red Hat and with Google, on how can we take the Cloud Foundry services infrastructure, it's called the Cloud Foundry Service Broker API, and turn that into a commons. How can we share the adoption that's gone in? How do we share the 5 years of hardening that's gone into that API, the feature completeness, the interactions that have been tested? And so we've created a great working group between the two foundations to figure out how does the CNCF participation, how does CFF participation make us more effective collectively? Because what we've got to do is recognize it's a moment in time where we have to create a coherent open platform. It's good to have lots of platforms, but let's have interoperability between Kubernetes and Mesos and Cloud Foundry. Creates better opportunities for all of us, and then possibly standardization and unification in the distant future.
I read what you wrote about, I read the interview you did with Matt Assay. In
his rude Q&A.
Yeah, he was.
Those were pretty rude questions.
He was. Yeah, it was. There was kind of there was an intensity there in the questions, but one of the things that resonated for me from what you said in that article is about how we've moved beyond the first dimensions of what we understand as cloud infrastructure, beyond AWS, into kind of more of a concepts about how you actually use shared infrastructure across multiple cloud environments. And it made me think immediately of BOSH.
Yes.
And how that applies. And then
yeah.
Why you would see in a participation of a Google, who we talked this morning about the services API and their use of BOSH and how they're implementing BOSH. And so you're starting to see this, that constellation effect again start to really take shape.
Yeah, I think there's a pattern there, right?
Yeah.
We've seen Google, Amazon, and Microsoft all contribute to the BOSH CPIs that look after their clouds. And BOSH is kind of a mechanism for future proofing. When we look at the BOSH Cloud Foundry linkage, we know a couple things. We know that no one's smart enough to know what cloud is going to be the most popular in 10 years. And we know that companies that are still in business in 10 years will still be running applications or some version of the ones that they built today. Two basic rules of enterprise, right? You're going to stay in business and you're going to have legacy. The act of writing code is the act of creating legacy software.
Right.
So BOSH's role in that is to be able to say, the elastic runtime in Cloud Foundry takes care of running your applications, whatever version they have to be, whatever security vulnerabilities have to be patched, manage all those things on the fly. That'll get tracked. BOSH enables you to move to new clouds. So clouds that haven't yet been invented yet can have a BOSH CPI built for them in 2018, 2019. And then we know you'll be able to redeploy existing Cloud Foundry apps to the new clouds without changing your developer experience and hopefully without changing your operational stance very much. So I think that pattern of BOSH as a multi-cloud deployment, resource management, orchestration engine that supports a big runtime like Cloud Foundry, that's super powerful. And in fact, we had a whole BOSH day 3 months ago. It was as big as the first Cloud Foundry Summit in 2013. Like we had 250 people show up to spend 8 hours to do a dozen talks and some workshops on what is BOSH as a platform. What else could we do with it in the industry?
So with every pattern, there's an anti-pattern.
Sure.
What are the anti-patterns that you observe that you are thinking about now? I mean, just off the top of my head, I think of Oracle as an anti-pattern.
I think Oracle is playing a long game. I think they're quite confusing. I'd say that the key anti-pattern that if I could offer them heartfelt advice, offer the same advice to Larry Ellison that I offered to Steve Ballmer when I was an employee at Microsoft, is be more open. Actually discuss your plans in advance. Don't show up and surprise people with all this clever stuff, but do what we're doing with Docker and Kubernetes and Mesos and Cloud Foundry. You can feel like you're competing for resources, competing for opinions and goodwill. If you're going to do any of that, start by articulating the problem you see, how you think you might solve it, and invite people to the game. It's what we don't yet see from Oracle. Maybe we'll see that in the future. I think a major anti-pattern, and I lived through this in my last company, Apogee, is don't design your infrastructure to run on one cloud.
Right.
So we had to do that because there wasn't a lot of multi-cloud thinking, there weren't a lot of multi-cloud frameworks at the time, and we built that in 2009, 10, 11, right, early days. The core APIs in a single cloud that you build your software on, they become like nerve endings, right? Heart, lungs, right? Your whole parasympathetic nervous system. Your ops team learns the ins and outs of that one cloud platform, like they know their own body.
Yes.
Fine, but you might need to move. Case in point, Apogee was acquired by Google in the beginning of September. So there's active speculation. I have no knowledge of what's going to happen, but active speculation, hey, most of Apogee's cloud customers are running on Amazon. With the Google acquisition, does that whole thing need to port over to GCP, right? What's going to happen? Now, if you're a software developer today in 2016, a massive anti-pattern is taking hard dependencies on cloud-specific APIs. That's insanity, because one thing that we know is the right cloud for you 10 years from now probably hasn't been invented yet.
Right.
Get yourself in a posture where you're going to be able to slip and slide, right? As the late, great Muhammad Ali used to say, float like a butterfly, sting like a bee. Right? So look at BOSH or a similar pattern to float like a butterfly. Don't have your feet rooted in the ground waiting for somebody to come and box with you, because you're actually going to be in big trouble.
Yeah, you already see the evolutions in hardware, for example, and there was a great Wired article last week about FPGAs.
Amazing.
In use at Microsoft. Going from 20. I mean, to me, that was like one of the first articles I read. Were like, now I can see the reality of AI, right? Because if you're going from 35-second processing times to 23 millisecond processing times, that's the difference right there.
Absolutely massive. I mean, the idea of being able to do special purpose computing at scale is quite fascinating.
Yeah.
I have the privilege of serving on the board of directors of a company called Teradici. Teradici has specialized itself in projecting PCs over the internet. So you can have your PC anywhere and run it on any other device. Because cloud has come along, now people are putting PCs in the cloud. So it's literally a headless PC. There's no physical display, but they are putting in GPUs, right? They're running these in Amazon, they're running these in Azure, and then somebody's getting their distance remote PC experience through a simple device that has nothing more than a screen, a keyboard, and a little bit of chip IP, right? So that can be programmed by an FPGA or a special purpose chip, right? Teradici has something called a Zero Client. It's a $50 piece of silicon, as opposed to the Altera FPGA, which is $1,000 to $2,000 per pop. One of the things that I take away from that is you realize how serious Microsoft's need is for changing the game in their compute performance when you realize, that $13.6 billion acquisition by Intel of Altera was based on lots of chips. Yeah, $1,000 to $2,000 chips. We're used to paying that for a server. That's just one chip that they're going to put into the data plane between the network port and where the CPU lands.
Yeah.
So there's a potential for this market for much smaller special purpose built chips that you can proliferate in a data center to pick up these kinds of remote PC workloads, IoT workloads, things that we haven't thought about yet, but when we think about these hyperscale compute environments really being a single computer, then we can start to say, well, what's the equivalent of a PCI architecture for a single PC for a hyperscale cloud data center? How do we start creating a renaissance of chip architectures and opportunities for daughter board providers to clip into, Azure, AWS, and GCP as the three hyperscale clouds?
So I read that Wired article. I think what you're saying resonates very, very much with what I read out of that, and what you're seeing also in open source communities. And Brian Cantrell was on the Arrested DevOps show with Bridget Cromhauer, and
he's one of the funniest smart guys I know.
Yeah, and he described this time as the age of cyber. It's the age of cyber dystopia and Aquarius. It's just fascinating, right? Because it is kind of a weird time, cyber dystopia time, where we do face this issues of, that very real issues we have with technology and their implications.
Yeah.
But yet we're in this time of of almost this liberating time like we've never seen before. We'll have to follow with that in another conversation.
It is an extraordinary time. I read a brilliant article, Krebs on Security, just posted in the last couple of days, talking about the ability of state and non-state actors to weaponize the Internet of Things for distributed denial of service attacks.
Yeah.
So one thing that we hadn't thought about is, in this amazing world where everything's computable and we're up to 50 billion connected devices by 2020 or whatever it is, you can start to attack these devices and take them over and make them remote spawn points. Grab 10 million of these devices and use them for a throwaway attack to end up censoring or destroying some infrastructure. So there is an active ecological process, right? There's I'm not sure it's a Cambrian explosion, right? But as you start to see this massive proliferation of devices, you'll see new exploits, problems and opportunities that never existed before at scale. We're going to have things, we're going to have venues like the New Stack, we're going to have conferences like the CF Summit, and thousands more, to interact as humans, to reason about, oh my God, what's the shape of this problem and how do we start to solve for it? It's going to take the whole mix of technology that we've invented since 1950. New chips, new software, new databases, old chips, old software, old databases, right? New wireless protocols, old wireless protocols. It's all going to have to come together kind of to deal with the world that we're creating.
We're putting sensors on the Pancake robot. We actually loaded Ubuntu Linux on it, and we're running it now with Ubuntu Linux. And the next step is to put sensors on the robot with an Arduino kind of chip to give it that. So we'll have to protect it from these state actors who want to take over our Pancake robot.
I would hate to see your Pancake robot used for evil. Mostly so far it's been used for good.
Good. Well, thanks, Sam, for having us here at the conference. Always awesome to talk with you. And we'll catch up real soon.
Alex, thanks a lot.
Yeah.
Appreciate it, man.
We'd like to thank Cloud Foundry, our sponsor, for these podcasts from Cloud Foundry Summit in Frankfurt, Germany. Cloud Foundry gives companies the speed, simplicity, and control they need to develop and deploy applications faster and easier. It's open source, easy to iterate, and built to scale. Learn more at cloudfoundry.org.